નમસ્કાર, હું આદર્શ છું. વેલકમ ટુ આદર્શ એજ્યુકેશન સોસાયટી.
Hello students, today we will study about the application of compound interest formula. This is the topic of standard 8 chapter number 8 comparing quantities. So till now we have studied about the formula of the compound interest, that is only for to calculate the money. But this formula we can use in many other places, like first is increase or decrease in population. Yes, we can use the formula in to count the increase or decrease in the population of a country, population of a city, right? Second thing, we can use it, the growth of the bacteria if the rate of growth is known. Yes, we can use this formula to find out the rate of growth of the bacteria. Third, we can use the value of an item if its price increase or decreases in the intermediate years. So if we have given that in some couple of the years the value of an item is increasing, but the rate of increase is we have given, then we can find out the value of that item after 2 years or 3 years. In the same way, if the price is decreasing, we can find out the final value after 2 years and 3 years. So yes, this is the formula we are using to find out the compound interest. That is, we are getting the total amount is equals to principal amount. 1, see here I have write down plus minus r upon 100 raised to n. So whenever we have to find out the increment in something, right, like to growth, here the bacteria is getting growth, right? So at that time we have to use the positive sign, plus sign. Okay, whenever we have to calculate the increase in the value of something, we have to use the positive sign. But as we have to, whenever we have to calculate the decreases in the price, then we have to use the negative sign, minus sign. So this is the formula that we have already studied. So let us understand one of the question from to use this application. Here we are taking the question number 9, question number 10 of exercise 8.3, right? So here we are taking the exercise 8.3, question number 10. Here we have given that the population of a place increased to 54,000 in 2003 at a rate of 5% per annum. So the first thing we have to find is find the population in 2001. Now here we have to think about that whatever the amount we have given, whatever the digit we have given, 54,000. This is the population in 2003 and we have to find out the population in 2001. That means you can compare it, the population in 2001 means the principal amount there we are putting into the bank or we are borrowing from the bank, and obviously if we return it back we have to add some of the interest in that and then we have to return it to back. So whatever the principal amount we are taking, we have to pay back the more amount. So here we can compare this 54,000 as a total amount, right, which is, we can say that the principal amount plus interest. So obviously the population is getting increased, that we have given in the question, and the rate is 5%. So here the rate we have given is 5%. So in the first case that we have to find out, here we have to take this 54,000 as a total amount. 54,000 as the total amount. Now, see there is a, how many years we have to take here? Value of n, 2001 and 2003. The time duration is 2 years. So we have to take n is equals to 2. So this situation we can say that whatever the population is there in 2001, it is increased every year by the 5% of the rate, and after 2 years the population will become 54,000. Okay, so here the population is getting increased, so we have to use the positive sign here. Okay, so let us apply this formula. A is equals to, that is 54,000. Okay, what we have to find? That is P. P means, here the P means not principal amount. Here the P means the population in the 2000 year, 2001 year, right? So 54,000 is equals to P1 plus R is 5 upon 100 raised to power 2, right? So here P remain as it is. We can cut it. 5, 20 is 100. So 20 will be the LCM. 20, 1 is a 20 plus 1, that is 21 raised to power 2. Here we have 54,000. Right? Now we have to apply this square to both these numbers. So we are getting P into 21 into 21 upon 20 into 20. Here we have 54,000. So let us make the P as a subject. So this 20 and 20 will multiply with the 54,000. So 20 into 20 into 54,000 upon 21 into 21. Okay, so let us simplify this. We can cut with the common factor 3, as 21 is also divisible by 3, 54,000 is also divisible by 3. So we can cut it with 3. So we get 7 here. If we cut here with the 3, we get the 18,000. In the same way, here also we can cut with the 7. 3s are 21. Here we can cut 6,000 into 3, that is 18,000. 3 is the common factor. So now what will remain here with us is this 2 to the 4, 4 6 are 24, and 1 2 3 4 5 zeros. 1 2 3 4 5 zeros are there. And in the denominator there is 7 sevens are 49. So when we divide these numbers, we get the answer 48979.59. Now see, this is the population, and population is never be in the decimal point. So we can take the approximate answer. That approximates. This is the sign of approximation. So we can take here is 48,979. So we are approximate round of it as 80. So this is the population is in the year of 2001, right? Here we have given that the population in 2003 is 54,000. So in the 2001, the population is approximate 48,980. It is the population increased at a rate of 5%, and within 2 years the population will become 54,000. Right? So now let us study the second portion. Second part that we have to find here is that what would be its population in 2005. So here we have to find out the population in 2005. See, the population in 2003, that is 54,000. Now we have to find out the population after 2 years. Here this population we get before 2 years. Now we have to get the population after 2 years. So now you can think about, this will be our principal amount. Here we can consider it as a P, 54,000. Again the rate will be the same, that is 5%, and value of n is also remains 2, because the time duration between 2003 and 2005, the time duration is 2 years, right? So now let us consider apply the formula, that is we have to find out the A, because what A will give us? A will give us the population in after 2 years, 2005. So this is the amount 54,000 will be our P. 1 plus R upon 100. Now what is the R? Let us put down the value of R, that is 5. 5 upon 100 raised to power 2. Because the year is 2, so we have to take the power is equals to 2. Now this 54,000 remains as it is. Here we know that 1 plus 5 upon 100, that we get the 21 upon 20 whole square. That means we can now write down it as a 21 into 21 upon 20 into 20. Right? Same thing we are getting here, so we can now directly write down as it is. So now 0, 0 will cut each other. This 0 will cut with this 0. 540 is there. We can cut it with the 2. So let us cut it with the 2. We get the 2 2s are 4. 2 2s are 4. What is the remainder? 4 14 is there. 2 7s are 14. 0 is there. 270 we get. Again we can cut it with the 0 or 2. We get the 2 1s are 2. 2 3s are 6. Then 1 is the 5 is 10 is there, so 2 5s are 10. 135. Now what we have to do here is that multiply this 21 into 21 is 135. 21 square, that is 441. We have to multiply it with 135. So let us check what we will get the answer. 0 0 441 plus 0 3 1s are 3, 3 4s are 12. 1 is the carry, 3 4s are 12 plus 130 plus 5 1s are 5, 5 4s are 20, 0 is there, 2 is the carry, 5 4s are 20 plus 2 22. So what is the total answer we are getting? 5, 3, 2 plus 2 plus 1, 5, 4, 5, 6, 7, 8, 9 and 5. So here we are getting the answer 59,535. So this will be the population of that area of that city after 2 years in the year 2005. So see, this is the method how we can find out this, how we can use the formula of compound interest to calculate the population. Okay, so this is all about this lecture. Thank you.
Thank you for joining us.